from graduating and whatever. Okay. Is it literally 6 weeks? Let me think. Graduation. So this is weeks. I don't know. Okay. 6. Yeah. Yeah. Wow. Right? Did you guys? Okay. All right. So we'll start everything as normal. NumPy, pandas, matplotlib, and then and I think I did this last class on Monday, where we imported New York City flights, and then we changed some of our import types to be objects. Okay, objects allow us to have basically it's like strings, but also with missing values, right? Otherwise, if it's numeric and there's missing values, it's going to convert it to floats. Okay, and then we created a function that will take the last 2 digits and first 2 digits of, or everything up to the last 2 digits of the timestamp, and then we turn those into hours and minutes, and we created a date object using pandas to date time function here. Okay, and then and we applied that to departure time and all of this stuff to get things into times, and I think we fixed this, and there we go. So now we have all of this, and we joined that up, and it takes a little bit to run because it's doing a bunch of these operations, and it's done. Okay. All right, so what if the exercise says find all flights that had an arrival delay of 2 or more hours? How do you think we can write this? Oops. So maybe before we get into this, I will do flights.info. Okay, and so these are the different column listings that we have, and we can also do flights.head. Okay, so if we want all flights with an arrival delay of 2 or more hours, okay, one thing we can do is we can run flights.location, so locate, okay, we're going to locate all the rows where the arrival delay, and because right now arrival delay is an object, okay, we have to turn it into a float. We have to convert it back to a number so we can do a numeric comparison. So we're going to do flight's arrival delay is greater than 120, okay, and we'll get kind of 10,000 of these flights. This is kind of just a glimpse of all of this. We can also, another option is you can check to see if arrival delay greater than 120, so more than 2 hours is one way to do it. Another way to do it is to check arrival date time minus scheduled date time and see if that's greater than 120, okay? And so we'll get true and false values here, and we can ask how many of these are greater than I guess 120, and we actually get different values. Okay, so if I say, so here we're doing arrival date time minus scheduled arrival date time, and we're getting how many of those are over have 120 minutes of difference, and we see that there's 7,400 flights. And over here, when we just said how many have arrival delays greater than 120, we're getting 10,000. Okay, what do you think could be going on? Okay, so one way to do this is we can do some set operations. Okay, so here I'm going to take this. This is the results. Okay, flights.location, where the arrival delay is greater than 120 minutes, and I ask what's the index, and we're going to store that as A. Over here I do pretty much the same thing, where I say arrival time minus scheduled arrival time is over 120 minutes, okay? And in order, when you do calculations with date time objects, you get this time delta type. The result is not a new number. It's a time delta object, right? So it talks about, and so if you want to talk about a time delta, you can talk about a difference of 120 minutes or a difference of 3 days or something like that. Because time is just stored in a very weird and arbitrary manner, right? 60 seconds to a minute, 60 minutes to an hour, 24 hours to a day. We're lucky that we're all accustomed to it, and that the whole world works on the same clock, because it would be quite a nightmare, right? Because it doesn't really make sense. I don't know. Is there a reason why there's 60 seconds in an hour?
There's not.
Or 60 seconds in a minute? Is there a reason why that? Is there a reason why we have 60 minutes in an hour and 60 seconds in a minute? I don't know. I would be curious. Okay. Yeah.
Can you upload this onto
Oh yeah, that's a good idea. Sorry. Thank you. All right, so let's add both of these things. Git commit draft 05, 02, and 03, and git push. And then all you have to do is git fetch upstream, git merge upstream master, right? Assuming you don't have merge commit issues. I think git, I don't know, maybe you're still not convinced about git's utility, but I think it's great. Okay. Is it showing up? Maybe. Okay. All right. But so here I ask for the index of this thing. So I'm going to have 7,474. This is all part of, like, these are the issues that you might face as a data analyst or something, is you're just working through a data set and you're just checking answers, and you gotta track down individual rows and figure out, like, why is something going on, right? And so here A is just if we ask what is A is just an index object, okay, and B is an index object, and then so you could ask what's the difference between these two, and we get a difference of 2,979. And the first one that's different is 151. So let's just go ahead and check that out and see why there is a difference. Okay, so when we look at this, we're looking at just one row in the table, all right? And it's a little bit, let's just see what happened, right? So it's supposed to leave at, so the scheduled departure time was 18:35. It was scheduled to leave at 6:30 in the evening, 6:35. There was an 8-hour, or is it 850? No, 8 hours and 53-minute delay. Okay, so it's supposed to leave. I don't know how to read this. Scheduled departure time, departure delay. Okay. And the arrival time was 10, and it was supposed to arrive at 9:50. I'm sorry, I can't, I'm having a hard time reading this. Okay, so the scheduled departure time was this, but the actual departure time was 8:48. And so what actually happened was that it was delayed and it departed the next day. So it was supposed to leave at 6:30, but it ended up leaving at 8 a.m. the following day. Okay, and right now the way we created our departure time and arrival time was we just took the date and we chopped this up and we said, well, this is 8 and this is 48, so we're going to turn that into 8:48. Okay, and then we took the current date in our thing and we said it was January 1st, and we just kind of pasted those together and we said therefore the departure time is January 1. But what we're missing is all the times where the flight got so delayed it pushed it into the following day, and we would actually need to update the way we calculate the departure times so that it's not January 1 here, but it's actually January 2nd at 8:48 the next day. Okay, so the flight departed the next day, but our date time columns don't reflect this. Okay. Here's another issue. The scheduled departure time says 10. Okay. But it should read as 0010, as in like 12:10 in the morning, okay? But when we export things or import things as a CSV files often will drop leading zeros because if it thinks it's a number, and so things become issues, okay? So so this is here's a thing where I've got an array of strings where I've got A and nothing, C and D, and you can ask where is you can do a where operation which will replace kind of these things where it's true. Okay, so you can always ask like numpy if you're not sure. Okay, so numpy is going to choose a condition, and if it's true, it's going to plug in X, and if it's not, it's going to choose Y. Okay, so it's going to be so here's just an operation, right? So numpy, here's A range 0 through 9, and you can say where A is less than 5, return A, otherwise return 10 times A. Okay, so here I want if it's blank, replace it with 100, otherwise replace it with A. Okay, and so here I'm going to re-import my CSV thing, but we're going to do a few things. Okay. So the this time delta, the departure delay, this is recorded in minutes. So this was delayed 853 minutes, which is, how many hours is that? 12 hours is 720. So 853, I can't do math here. 72, 78, 84. So 14 hours and 13 minutes, okay? Which, yes, indeed, that's what it is. If you do 1835 plus 14 hours and 13 minutes, you're going to get 848 the next day. So, this is, I'm going to re-import all of my data, okay? And we're going to apply a few operations to kind of fix all of this, okay? So one is when we convert the time, we're going to do the same thing where we're going to extract the last two characters and the first two characters as the hour and the minute, okay? But as far as the hour goes, if the hour is blank, okay, we want that to actually be 00 to indicate that it's like 12:00 something in the morning, okay? So we're going to replace if the hour is blank, replace it with 0. Otherwise, use what is currently stored in the hour, okay? And then we'll do that, and we apply that. And then later on, as far as departure date time, we're going to take what's scheduled, and then we're going to take the departure delay, which is already recorded to us in minutes, and we're going to turn that into a time delta, and we're going to just add that to the departure date and time in minutes, okay? And so we're going to say like, so in that instance where it was supposed to take off at 6:35, and it was delayed 843 minutes, we're going to add 843 minutes to 6:35, and it will take us to 8:48 the following day. Okay, so we'll go ahead and do that. Is this okay what I'm doing here? And then so we do that, and then we do some cleanup where if the scheduled arrival time is lower than the departure date time, then that must mean it arrived the following day. So we're going to add 24 hours, similar to arrival date time. If the arrival thing is less than what it was supposed to, then when it departed, and then add 24 hours. Okay, so we'll go ahead and we'll clean all of this up, re-import all of our data, reapply all of these commands, and then we can kind of check just our result here. Okay, so this is what we saw earlier. It was supposed to leave at 18:35. It actually left 8:48, and now it's reflected correctly in that it was scheduled to leave 18:35 on January 1st, and it actually departed January 2nd at 8:48. Okay, and so this should clean up the issues that we encountered earlier. Okay, and this is the one where departure time is 10, but now we recognize this as being 12:10 in the morning, okay, on the following day, okay, and so this part's cleaned up, and now we can check if this results. So we can ask how many instances was the arrival delay greater than 120 minutes, and we did arrival time minus scheduled arrival time, is that greater than 120 minutes, and now we get results that match, okay? So this is just an example of like, this is how tedious data cleanup can be, right? And I think sometimes this grunt work of working through a data set is sometimes lost, and sometimes a lot of times it just means like, why am I getting results that don't quite make sense, right? If you're getting something, what we did was we had a logic check, right? We said I should check, how many flights were delayed more than 2 hours, and then I should also be able to see like, where was the departure time different from the scheduled departure time, and that should match, and we didn't get a match. And so it also meant hunting down individual rows, seeing what was up there, and then making the corrections as necessary. All right, so here's a few exercises that that I've done here, and these are kind of like dplyr type exercises, except we're doing pandas, right? So here, maybe I should make you guys work through some of these yourself. we can say, what are the flights that go to Houston? And the two airport codes are IAH and HOU. And so you can use the is-in operator, okay? You could say, locate the flights where the destination is one of IAH or HOU, and we can ask how many flights are there, and we get 9,300 flights. How many flights were operated by United, American, or Delta Airlines? And there is the same kind of thing, but we say carrier is one of UA, AA, or DL for those carriers, and we get 139,000 flights. There's a lot of flights every year, right? Okay, and then we can just ask, what about flights taking off in July, August, and September? Okay, and so here I'm doing departure, date, and time, where the date. Okay, so here the departure, date, time, if we look at it, is this thing, okay? And what we want to do is we want to use date time methods. So you do .dt, and this will give you access to the different methods that apply only to date time objects. Because here, if I tried to do .month here, it's going to complain because this part, flights, .departure date time, is a pandas series, okay? And you'll have methods that are related to pandas series, okay? If that series is of a certain data type, and ours is, you can use methods that are kind of exclusive to objects of that data type, or you could even try methods that you could try to kind of upcast them into different things. And so here, you could call like str for string methods, and here you can call dt for datetime methods. And so datetime methods give you access to things like what's the month and what's the hour and things like that. So here we're going to call dt for datetime methods, and we want which month, and then we're going to say is that month in 7, 8, or 9. And so we call that, and we get 84,000 flights in just those 3 months, right? So here, here's a question where it arrived more than 2 hours late, but didn't leave late. Okay, so this is like something happened on the flight, right? And so here's just a few things where it departed at 2:19 and it was scheduled to leave at 2:20, but then when it was supposed to arrive at 3:50, but it arrived at 5:54. Okay, so for whatever reason it took 2 hours longer than it was supposed to. And so, I don't know, there's probably stories for each of these flights, okay? There were only 29 flights like that. I'm just curious. Yeah, I don't know if there's anything special about these things. Okay. And then here's just the opposite. They were delayed. They left over an hour late, but then they arrived less than 30 minutes late. So you can check that. And there's quite a few flights like this, I believe. So there's 2,000 flights where they left an hour late, but then they made up a lot of that time in the air. So these departure delays are interesting. Okay. And then here we're just asking which flights departed between midnight and 6 a.m. and 8,000 flights, so not too many. It's kind of people don't generally like to take off in those hours, but they exist. Okay. All right. So now we can ask questions that use group by. Okay. So here you can say take your flights and then group them by weekday. Okay. So we're going to take the departure date and group by the weekday and the departure date. Okay. And then we can ask it to count it, right? And then when you look at the weekday, so you can always look all of this stuff up, right? Pandas, daytime, weekday, and it tells you where Monday is 0 and Sunday is 6. Okay, so it's 0 indexed, and so this feels a little odd, but we'll go ahead and get this, and we can see that. So this is Monday, Tuesday, Wednesday, Thursday, Friday. Saturday is actually the least busy, okay, and Sunday is that. Okay, so it looks like Monday and Tuesday are the busiest. We can rename. So if I take W and if I store W, okay, I can take this and I can rename our index here, right? So W, if we ask just what the index of W is, it's the numbers 0, 1, 2, 3, 4, 5, 6, right? And so what we want to do is we want to rename, and we're going to just map all of these things with a dictionary, where 0 is going to be Monday, Tuesday, so on and so forth, where 6 is Sunday. And we're going to apply it to this, and now we get it as a data frame. Okay, so here if I turn this into a data frame, I take the series and I turn it into a data frame, which will create the index, and then we're going to just rename the values in the index here using rename. If you've got a data frame, you can use matplotlib, and we haven't really covered matplotlib, but the command you're going to use, and I guess I'll probably have a separate lecture just talking about some of the things you can do with matplotlib, is the command you're going to use to get it going is going to be matplotlib.pyplot, and you'll import that as PLT. Okay. And so Pandas has some default kind of built-in ways to make plots. Okay. So you can just say take the data frame that we've just created here, and we're going to say I want to make a plot, and there's different options. And you can say I want to make a bar plot. You can specify your color, and then to make it show up, you say plt.show, and this will make the bar plot right here. Okay, but if I didn't do this, I think it'll default to making a line plot. But the line plot is fit so that it kind of connects it with the lines, and the largest value is up here, and the smallest value ends up down here. With a bar plot, it knows to kind of set 0 as the horizontal axis here. Okay, or I mean start 0, and so you can see that basically Monday through Friday it's about the same, right? And I know people talk about flights being cheaper on Tuesday or Wednesday, but I'm not sure why, because the volume of flights is like the same for all of those things. Okay, but we don't have flight price information. This is just the flight information itself. Okay, so we went through all of this trouble of defining a weekday, there's actually the date time object is there's something you can call weekday name, right? So all of these things you can always just type into Google pandas DT methods, okay, or pandas.series. Well, that's not what we want. Let's see. Series essential basic functionality. Is it datetime attributes? Let's see. DT methods, or I want the list of the things I can run. Series.dt. Okay. All right. Now I don't know why this is only showing this. Accessor for datetime-like properties of the series values. Okay. I was hoping for more of these things that we can do. A lot of times, if you're not sure, you can just ask for like date time, and then you say want it like day of the week. Right. And there's probably something that you can pull. Okay, there's day of the week, and then it will also say weekday and day name. Okay, so here it says day name. This is something that's new only in version 0.23, which is a recent thing. Okay, so I think when I first did this. So anyway, you can do like weekday name, and it automatically pulls it for us. And it by default sorts it alphabetically, which isn't super helpful for us. Okay, and then you can also pull out day name, and you can specify the language that you want, right? So if you want to specify Spanish, or I don't know, what other can I do? German. What languages do we speak here? I don't know. Huh? English? English is not going to be exciting. Okay. I don't know. Can I do like Japanese? Oh, it tried to do something. Okay. I don't know. Maybe, huh? Mandarin. Let's see. No, it doesn't like that. I don't know. I don't know what languages are. Yeah, so we can do Spanish, probably Western languages. It's our programming bias. I don't know. I'm just curious. Pandas day name. Languages. Weekday name. Okay. Well, anyway. All right. Lots of things are out there, right? Okay. So here we can create what's called a multi-index. So in all of these things, we've been doing group by like which day of the week and things like that. Now we can group by 2 columns, okay? And so here I'm going to group by carrier and origin. So the origin is going to be which airport they've left, and there's 3 airports in New York, okay? So I'm going to go ahead and I'm going to just group by these 2 things, and we're just going to get the count of the flights. Okay, and so so here, I don't know what carrier is 9E, but we can see for these the origin it leaves from Newark and JFK and LaGuardia, with these kinds of frequencies, where American Airline uses JFK and LaGuardia a lot more heavily than Newark, and same with Delta, whereas United Airline uses Newark quite heavily and doesn't use JFK or LaGuardia as much, okay? And WN is Southwest, only goes to LaGuardia and Newark, and does not fly to JFK. So these are just kind of just something here. And then if we explore the result of this result, and we ask what is ask for the index, okay, this is we get something back called a multi-index, right? And there's two levels, 9E, one with the carrier names and one with the origin names. And here it it also provides kind of the code matchup that basically tells us, which of these show up, right? So in the end, for Southwest, which only has Newark and LaGuardia, it tells us, these last three are EWR, LGA, and LGA, and we can see it matches with 0, 2, and 2 for EWR and LaGuardia there. So we get something back called a multi-index, okay? So when you have a multi-index, you can do something called, you can unstack them, okay? So so do you remember gather and spread from tidier? Okay, it's kind of like that. So what can we do? We could, the equivalent of spread would be to unstack this thing. And so what we're going to do is we're going to create basically a two-way table where on the rows we will have the carriers and the columns will be the origin. Okay. So so I'm going to just take this exact thing here. Okay. Flights grouped by carrier origin flight count, and I take that and I just pair that with unstack. Okay. And unstack will take your multi-index and take the second index of the second portion of the multi-index and make them into column headings. And so we get this, and it makes a data frame for us, and we can see indeed Southwest has 6,188 flights from Newark, no flights from JFK, and 6,087 from LaGuardia, and we can see all of these flights listed out this way. Okay, I think this is kind of neat, right? So so you can use the multi-index and then unstack them to get this. Pandas also has something called pivot table, okay? And this is kind of a, I don't know if you've ever made a pivot table in Excel, but it's kind of like that, except you're typing out your command here, okay? And so pivot table basically does the same type of thing, except you're going to specify kind of the column to summarize. Okay, so we're going to take the column flight, or and then we're going to kind of aggregate these, where on the horizontal the rows, the index will be the carrier and the columns will be the origin, and then as far as the aggregate function goes, we're going to call count. Okay, and we get the exact same results that we got up here. Okay, so pivot table will do the same thing. They're just kind of two different ways to create the same thing. Okay, one is you create the multi-index and you unstack it, and here you can create the pivot table directly. And then here, look what I'm doing. I'm taking our pivot table and then I just tack on another method called plot bar, okay? And so here I'm going to go ahead and I'm just going to plot this as a bar chart, and I'm throwing in the option stacked equals true, and it creates a stacked bar chart, okay? And so we can see, really we get a sense of, JetBlue really likes JFK, EV, I don't know what airline that is. They really like Newark. United Airlines really likes Newark, and the other ones are kind of balanced out. If you don't use the option stacked equals true, so these are basically I'm just using the pandas data frame and I'm just tacking on plot. And if you don't use stacked equals true, then you get kind of this side-by-side bar chart type of deal here, okay? And so this gives us a sense of kind of like the biggest carriers, which are B6, Delta, EV, and United Airlines, right? And so I was just kind of curious. I did this thing. So here I said, let's just look at Newark, okay? And so for Newark, we can see that United Airlines and EV fly out the most, okay? So here I thought, let's, so United Airlines and EV are the heaviest things, and so I just thought maybe we could do an optional analysis later. I guess I didn't really get into it, but we could see, what proportion of their flights are delayed versus others, and I don't know if there's any kind of pull there or if it doesn't matter, right? I think as far as air traffic control goes, I think they're pretty professional and they don't really let all of this political stuff get in the way. But and then I did a few more exercises here. Here are the ones where the flights are going to LA area airports. So that's Los Angeles, Burbank, Ontario, and Long Beach. And so I just did that, and I just wanted to make sure. And we actually have no flights from New York to Ontario. And so and then we can count how often the flights go, and pretty much LAX gets the most, no surprise, but Burbank gets basically one flight every day, and Long Beach maybe gets one or two, about two flights or a little bit less than that every day. And as far as the airlines go, there's basically 5 airlines that service New York to LA. United, American, JetBlue, I think Virgin, and Delta. Okay, and then and here we did. I took this and I grouped by destination, and then I did the carrier counts, and we could see JetBlue is the only one that goes to Burbank, and Long Beach, everyone else only goes to LAX. And anyway, this is what we have. Okay, we'll end here for today. I've got more to say about pandas, and I'll write up an assignment for you guys to work with pandas as well. Okay, have a good weekend. We'll see you next week.